Welcome to Between Anya and Indigo. In today's episode, the Turin Shroud, Blood, Radiation and a Mystery Reignited, we explore new 2024 findings that challenge what we thought we knew. From blood chemistry and trauma clues to strange radiation and disputed carbon dating, we peel back the layers of one of history's most mysterious relics. Could this ancient cloth hold the imprint of the impossible?
You know, you've brought some really fascinating stuff for us to unpack today.
Yeah.
This is all about the Turin Shroud.
Yeah.
And, you know, for folks who have been following along, this is obviously something we've touched on before.
Right.
But we're going to be going really deep on the science today, and specifically focusing on the blood evidence that's analyzed in this very recent paper from 2024.
Wow, very recent.
But we also have some excerpts from other sources that are going to help us kind of get into this long debate about the radiocarbon dating results.
Right.
So our mission today is to really kind of understand what these detailed scientific findings can tell us about the shroud.
Yeah.
And, you know, cut through the complexity and really understand what we can learn.
I think that's a great goal because the material you've shared really highlights, you know, how science can be used to investigate these ancient artifacts.
Yeah.
And we've got cutting edge analysis literally at a microscopic level of what appears to be blood right next to, you know, these big questions about the shroud's age.
Right.
So, yeah, I'm excited to unpack all of this.
Me too. So let's just jump right into it.
Okay.
We've got this 2024 paper.
Yes.
And it starts by looking at the macroscopic evidence.
Okay.
So that's just stuff we can see, you know.
Right, with the naked eye,
Yeah.
or, you know, with normal photographs.
Right.
And one of the things that really stands out right away is that there's this possible presence of fluid kind of near the side wound.
Right.
That looks like it could be pulmonary edema.
Okay.
Now, for you, what's the significance of finding something like that?
Well, you know, if this is actually fluid from pulmonary edema, which is, you know, fluid in the lungs, essentially, it suggests that there was some very serious physical trauma leading up to, you know, whatever moment is captured on the shroud. And, you know, fluid accumulating in the lungs. That's going to make it really hard to breathe.
And that's a condition that can come from, you know, a pretty bad injury. And the fact that we've seen similar things on the Shroud of Oviedo, another historical textile, really kind of makes you think, you know, is there a pattern of trauma here with these relics?
Yeah, that's fascinating. Now, sticking with the side wound for a second, the researchers actually go through in this paper and they map out all the different directions that the blood seems to have flowed.
Wow.
So they're talking about vertical flows, angled flows, even horizontal flows, as if the body had been lying down.
So, like, at a different points in time.
Yeah, it's like reading this silent narrative of movement.
Oh, that's really interesting.
What do we learn from all these different directions?
Well, you know, if the blood had only flowed in one direction, it would mean that the body pretty much stayed in the same position the whole time.
Right.
But because we see these changes in direction, you know, from vertical, maybe while the body was hanging, to angled, perhaps during lowering to horizontal when it was laid out, it really suggests that the body was moved after the initial, you know, wounding.
Right.
And, you know, this fits in with a lot of the historical accounts
Right.
of, you know, removing a body from a vertical position, transporting it, preparing it for burial. So it's like a timeline of the shroud and the body interacting.
Yeah, wow, that's amazing.
Yeah.
Now, moving over to the left arm, the researchers actually identify 3 different types of what they believe to be blood.
Okay.
And they're basing this on color.
Right.
So we have bluish blood, we have reddish blood, and then there's a yellowish stain or something that's visible under UV light.
Okay.
And they seem to think that the bluish is post-mortem leakage.
Yeah.
The reddish, they think, might be pre-mortem stains that have been altered by this process called fibrinolysis.
Right.
Now, can you explain what fibrinolysis is and why that matters?
Sure. So fibrinolysis is basically your body's natural way of breaking down blood clots.
Okay.
So you can kind of think about it as the system that prevents clots from becoming these permanent blockages.
Okay.
So in this case, you know, blood that was shed before death, you know, it may have clotted while the person was still alive.
Right.
Or shortly after they died.
Right.
And if the shroud came into contact with the body, you know, maybe in a humid environment like a tomb,
Okay.
it could have actually encouraged fibrinolysis.
Right.
And that could have changed how those reddish stains now appear.
I see.
And then those yellowish traces,
Right.
which are identified as serum, which is the fluid part of blood,
Right.
that suggests that, different components of the blood separated.
Right.
They sort of migrated at different times.
Okay.
And that gives us a little more information about what was going on with the wounds.
Okay.
And the fact that they also see serum on the right foot.
Right.
It's another little detail that ties different parts of the image together.
Yeah. So here's something that really made me stop and think when I was reading this paper. They actually found bloodstains outside the main body image.
Oh, wow.
And specifically, there's a scourge wound on the right shoulder that shows up in the dorsal view.
Okay.
Now, given that the leading hypothesis is that the image itself was formed by some kind of radiation
Right.
that requires proximity to the body,
Right.
how do we reconcile that with the fact that bloodstains would have required direct contact
Yeah.
in an area where the image might not have been as intense?
Yeah, that's a really good point. And
Yeah.
this is something that challenges a simple explanation for how everything got onto the linen.
Right.
But the researchers propose that if we think about the body interacting with this vertical electric field,
All right.
which is their idea for image formation,
Right.
the field strength would have been weaker on rounded areas like shoulders because
Okay.
of the way they curve.
I see.
So the energy transfer may not have been enough to create a full body image in those spots.
Right. Right.
But direct contact between the skin and the cloth could still allow blood to transfer. So it means the image and the blood stains might have formed in different ways,
Okay.
but maybe related ways.
Great.
It's an important distinction.
Yeah, and this is something that I think, people who haven't really dug deep into the science might not
I
realize.
think you're right.
That it's not just one thing that explains all of this.
Exactly.
There are these separate processes at play.
Yeah.
And then another thing that just kind of blew me away was the sheer number of scourge marks that they counted.
Oh, yeah.
They said 372 scourge marks, and one of them even appears to be on the head near the right eye.
Wow.
I mean, that just speaks to the brutality
That does.
of what we're looking at here.
Right.
I mean, that's just a huge number.
It's a really powerful image just thinking about that number.
Yeah.
And that detail about the mark on the head,
Right.
potentially affecting the eye, it really adds to that whole picture of suffering.
Yeah.
Whether it was specifically from a scourge or something else like a thorn, the
Yeah.
fact that there's an injury in that area.
It's very powerful.
Yeah, absolutely.
Yeah.
And the last thing I want to touch on about the macroscopic evidence is this really interesting experiment they did.
Okay.
They took just 3 cubic centimeters of colored fluid and
Okay.
they put it on linen.
Okay.
And the stain that it created was pretty comparable in size to the side wound stain on the shroud.
Huh.
So their takeaway is that, maybe less than 10 cubic centimeters of blood
Wow.
could have caused all the staining on the shroud.
That's a lot less than I would have guessed.
Right. It seems counterintuitive.
It does.
But what do you make of that?
Well, it really shows you how efficient linen is
Okay.
at absorbing and spreading liquid.
Right.
Probably because of capillary action.
Right.
So it challenges the idea that you would need, gallons of blood to
Right.
create these stains. It's a
Yeah.
very important point to think about when
Yeah.
you're trying to figure out if these patterns could have been from a real event.
Yeah, absolutely.
Okay, so now let's dive into the microscopic world of
Okay.
this evidence.
All right.
So we've got 3 different types of blood that they identify: type A, type B, and type C.
Okay, 3 types.
Now, type A, this is the one that was found on those stir P tapes
Okay.
from 1978.
Right.
And these are really, really tiny donut-shaped particle.
Oh, wow.
Most of them are only about 0.7 micrometers in size.
That's tiny.
Yeah, that's really small.
Okay.
Now, they did elemental analysis, and it confirms that these particles contain components of blood.
Right.
But there's way smaller than typical red blood cells.
So what are they?
Yeah, so what are these microcytes? What
Right.
are the theories?
Well, the size is definitely the big thing here.
Yeah.
And the researchers are saying that these are shrunken red blood cells.
Okay.
Erythrocytes is the fancy word.
Okay.
And they're saying it was uncoagulated blood and it got super dehydrated over time within the linen.
Okay.
They even point to some studies on ancient remains
Right.
where they've seen similar shrinkage.
Interesting.
But here's where it gets really interesting.
Okay.
They did their own experiments.
Okay.
And they mixed human blood with substances like urea,
Okay.
aloe,
Yeah.
and myrrh.
Right.
Things that could have been used during burial.
Right.
And they found that the blood shrank even more
Wow.
down to these submicrometer sizes.
Wow.
Now, remember how they found those high levels of creatinine
Right.
in the type of blood?
Right.
Those nanoparticles tell us that the kidneys were under a lot of stress.
Okay.
So it's actually very plausible that there were high urea levels in the body.
Okay.
And this also helps explain why we don't see any intact white blood cells.
Right.
Which makes it seem like this was post-mortem blood.
Okay.
So we've got post-mortem blood
Right.
that shrank a lot, maybe
Right.
because of dehydration
Right.
and
Right.
interactions with burial substances.
Okay.
And all of this is happening in the context of someone who was under incredible physiological distress.
Yeah, it's really painting this vivid picture
It's-
of the suffering.
Yeah.
Now, type B is different.
Okay. How so?
So type B, they describe as fragments of blood crusts.
Oh,
So they're darker, they're more solid,
Yeah.
and they found them mostly in dust that had been vacuumed from the face
Okay.
and the gluteal area.
Okay. Interesting.
Now, unlike type A, these fragments don't have those characteristic red blood cells.
Oh, so this is pre-mortem blood then, right?
That's what they're thinking,
Okay.
that it had already clotted.
Okay.
So what do we learn then?
Well, it means that this was probably blood that coagulated before death
Okay.
or very shortly after.
Okay.
And maybe it wasn't exposed to the same conditions after death or
Right.
the burial aromatics that could have affected type A.
Okay.
And there's another interesting thing here.
What's that?
They did Raman analysis on a sample from the gluteal area,
Right.
and it showed signs of partial burning.
Oh, wow.
So that could mean that this piece of evidence is linked to the fire in Chambéry in 1532.
Oh, wow.
Remember, the shroud was damaged in that fire,
Right.
so some of the material might have been moved around after that.
That's a good point.
Yeah.
Now we also have type C,
Okay.
which is really rare.
Okay.
They only found it in dust from the face area.
Yeah.
And these particles are also donut shaped,
Okay.
but they're larger, so they're between 2 and 5 micrometers.
Okay.
Now, they haven't been able to determine the composition because there just wasn't enough of it,
Right.
but they think the larger size might be because it came into contact with oily substances that were applied to the face.
Okay, so how would that have prevented the shrinkage?
Well, they're thinking that maybe those oily substances
Okay.
acted as a barrier. So they prevented the erythrocytes from
That's
fully
just-
dehydrating and shrinking
Okay.
down like we see in type A. Now, there's also this SEM image that suggests this type C might be what's called an echinocyte.
The kind of thing.
Yeah, and that's a type of red blood cell that has kind of a spiky appearance,
Oh, interesting.
which can indicate changes in the blood chemistry. Okay.
So again, it kind of suggests that there were these different physiological conditions
Yeah.
at play when
Right.
this blood was deposited.
That's really interesting.
Wow.
So 3 different types of blood?
Yeah. 3 different types of blood.
Oh.
Now, beyond those 3 types of blood, they mention a few other interesting microscopic findings.
Okay.
So they talk about possible traces of fibrin in the fibers
Okay.
that are associated with the type A blood,
Okay.
and specifically in the wrist areas.
Okay.
And then there's also this stacking of blood particles
Okay.
that they observe that seems to align with those lines of that theoretical electric field that they talk about for the image formation.
Interesting.
And then there's the presence of what they call earthy materials.
Earthy material. That.
So it's basically clay and limestone
Oh, okay.
that are typical of Jerusalem.
Okay.
And they find this stuff mixed with blood and pigments.
Oh, so that sounds like contamination.
Yeah, like from handling.
Yeah, or maybe even contact with some of those painted copies of the shroud.
That makes sense.
Yeah.
Yeah.
So what do you make of all these extra little findings?
Well, if that fibrin is really there,
Right.
it could be leftovers from the blood clotting process,
Right.
type A,
Right.
and the stacking of the erythrocytes, aligning with that proposed electric field.
Right.
That's a pretty interesting connection
Yeah.
to their hypothesis.
It is.
And, it also ties into that beta activity they detected,
Right.
and then that earthy material.
Right.
That's a really strong indicator that the shroud probably touched soil and dust in Jerusalem,
Right.
and maybe even pigments from those artistic copies,
Right.
which, is a problem when you're studying old artifacts that have been copied a lot.
Yeah. For sure.
Yeah.
But what do you think about detecting ionizing radiation in these blood samples?
Well, it's certainly not what I expected.
Right.
It's a remarkable finding.
Yeah.
And, if this beta activity is confirmed,
Right.
it raises some really big questions.
Yeah.
The researchers admit that this is preliminary.
Right.
They've had limited samples, and there could be some influence from the surrounding material about this particular blood residue.
Right.
And, the possible gamma activity in type B.
Right.
Even though we need more sensitive instruments to confirm it,
Right.
just adds another layer of mystery to all of this.
Right.
If we can verify that there's ionizing radiation in the blood stains, that would be a huge discovery. And it could really change how we think about the shroud.
Absolutely, yeah. So then they go on to examine how these different blood types fluoresce under UV light. Now, the type A, it shows this orange-red fluorescence, which is different from what you would normally see with older human blood.
Oh, really? What do you usually see?
Usually it appears darker.
Okay.
And so they have a theory about this.
Okay, what is it?
They think it could be bilirubin.
Bilirubin.
Yeah, which is a byproduct of red blood cells breaking down.
Okay.
When someone experiences extreme trauma.
Right.
And then they even suggest that the beta activity itself could be contributing to this.
Interesting.
And then they also talk about alkalosis from high urea and that hypothetical electric field and how all of that could affect how the bilirubin fluoresces.
Okay, that's a lot of factors.
It is. And what's really interesting is that the serum that's associated with type A shows up with this greenish fluorescence
Under UV light.
Interesting.
while type B doesn't show any fluorescence at all.
Some more differences.
Yeah, even more differences. So what are your initial thoughts about these fluorescent properties?
Well, the fact that type A fluoresces differently really makes you think.
Yeah.
It's not typical for old blood stains.
Right.
So that bilirubin hypothesis, which ties back to that severe trauma, it's plausible. And we need to look more into the beta activity to see how it might be playing a role. And, the fact that type B doesn't fluoresce, that just reinforces the idea that we're dealing with blood in different states or conditions.
Right.
And remember, they first saw fluorescence in the bloodstains back in 1978.
Oh, that's right.
With the Stirpe team.
Yeah.
So this isn't something brand new.
Right. It's been observed before.
Exactly.
But I think the technology has advanced a lot.
Oh, yeah. For sure.
Since 1978.
Absolutely.
So we're able to look at it in more detail now.
That's really cool.
Yeah. So they pull all this together, this microscopic and macroscopic evidence.
Yeah.
And they start to talk about how these findings actually align with the medical realities of Jesus' suffering.
Okay.
As they're described in historical accounts.
Right.
So they're looking at those high urea levels that suggest kidney problems, the likelihood of blood clotting issues because of all the blood loss, how uremia would have impacted breathing, and then the effects of dehydration.
Yeah.
So it's painting this really, grim, but physiologically consistent picture.
It is.
So what do you make of how they've connected all these dots?
I think it's remarkable how they've taken these tiny findings and linked them to the potential consequences of the torture and crucifixion. The evidence of kidney stress, the potential shock from blood loss, the way uremia would have affected breathing. It all fits together in this really sad but plausible chain of events. They even connect those oily burial substances to the way the type A erythrocytes continued to shrink. And their interpretation of the blood and water from the Gospel of John as potentially serum and pleural fluid from pulmonary edema, maybe because of a chest injury or the strain on the heart. That's a really possible explanation for why there would have been breathing problems.
Yeah, it's really fascinating.
It is.
And they ultimately conclude that all these things working together probably led to a faster death on the cross. Due to what they call hemopericardial infarction.
Hemopericardial infarction.
Yeah, so basically it's a critical heart event caused by fluid building up around the heart.
I see.
So this is their hypothesis based on all of this evidence that they found.
So it wasn't just like they were on the cross for days and days.
No, it was a much quicker process.
Yeah, it was this cascade of physiological stress.
Right.
The scourging, the blood loss, uremia, dehydration, and any other injuries. It could have all led to this really fast decline. And then this heart event. And that detailed analysis of the blood, especially type A, gives us these tiny little clues that line up with these really severe medical conditions.
Yeah, it's incredible, the detail
It is.
that they're able to get from these tiny little samples.
Yeah, it's amazing.
So we do need to talk about the elephant in the room, which is this radiocarbon dating from 1988. that suggested that the shroud was from the medieval period.
Right between 1260 and 1390 AD.
Yeah.
Yeah.
And this new paper really raises some concerns about those results.
Okay.
So they point to inconsistencies in the samples themselves.
Okay.
So they had a high chi-squared test.
A high chi-square test.
Yeah. They're worried about potential contamination,
Right.
especially near where that raised patch was removed. And they even suggest that there's a gradient in the carbon-14 dates.
A gradient.
Yeah, across the shroud sample.
Interesting.
Which would indicate some kind of systematic influence.
So it's not just random variation.
Yeah, exactly.
Okay.
So what do you make of these inconsistencies?
Well, a high chi-squared value
Right.
in the raw data,
Mhm.
that tells us that the samples they
Right.
tested,
Right.
they weren't as uniform as they should
Right.
have been for reliable
Right.
dating.
Right.
And, the fact that they found different chemical compositions in UV fluorescence, here the raised
Right.
patch, which we know was handled
Right.
a lot,
Right.
that really raises concerns about contamination
Yeah.
affecting those carbon dates.
Right.
And then that linear gradient
Right.
in the carbon-14 levels,
Okay.
that's a strong
Yeah.
hint that something was affecting the results that wasn't related to age.
Right.
Yeah, it's not
Yeah.
random.
Yeah.
It's
And then it
systematic.
gets even weirder.
Oh, really? Weirder than
Yeah,
that?
so they found this incredibly strong correlation, really, like
Okay.
99.93% between
Wow.
how much the dated samples fluoresced under UV light and
Okay.
their carbon dates.
So the more fluorescence, the older the date.
Yeah, basically.
Wow, that's a really strong link.
It is. It's statistically very significant.
Yeah.
So what does that tell you?
Well, it tells me that whatever's causing that fluorescence
Right.
is probably messing with the carbon-14 measurements.
Right.
Which means that it's not really telling us the true age of the linen.
Right.
The researchers are saying that you could basically predict the carbon date
Right.
just from the fluorescence,
Wow.
which means the carbon dating isn't very reliable.
Yeah.
It's really interesting.
Yeah, and then they bring up some other concerns that have been raised before, that the
Okay.
presence of cotton fibers in the samples
Okay.
and dyes,
Okay.
and possible weaving repairs that we can't even see,
Okay.
and even just rogue threads.
Wow. So a lot of things that shouldn't be there.
Yeah, and all of that suggests that there could have been manipulation, or that they weren't actually dating the original material.
Okay.
So these findings are really building on the work of Ray Rogers
Right.
and others
Yeah.
who have been skeptical of that 1988 dating.
Right.
And it just makes you wonder if
Mhm.
they were actually looking at pieces of the shroud that were representative of the whole thing.
Right. Good point.
So they do touch on some alternative dating methods.
Okay.
And one of those is the vanillin decay analysis.
Vanillin decay analysis.
Yeah, have you heard of this?
I have.
Okay, so basically it suggests that the shroud is actually older than 1,300 years
Okay.
because the main part of the shroud doesn't have any detectable vanillin,
Okay.
while the area that they took the samples from for the carbon dating does. So again, it's like that area is different.
Right. It's not representative.
Yeah.
Yeah.
And then there's the micromechanical dating of the linen fibers.
Micromechanical dating?
Yeah.
What is that?
So this was done by Giulio Fanti and his team.
Okay.
And they basically analyzed the physical properties of the fibers themselves.
Ooh, wow.
And they came up with an average date of around 33 BC,
33 BC.
plus or minus 250 years.
Okay.
So that's a big range,
It is.
but it's definitely pointing towards a first century origin.
Right. So much earlier.
Yeah, much earlier.
Yeah.
So what do you think about these alternative dating methods?
Where that vanillin analysis,
Yeah,
it's a really good independent piece of evidence
right,
that challenges that medieval dating.
right,
And, the vanillin levels being different
right.
between the main shroud and that carbon dated area.
Yeah,
Again, it makes you think that maybe that sample wasn't representative
Right.
of the whole shroud,
right.
the micromechanical dating.
Thanks for joining Between Anya and Indigo. The Turin Shroud blurs the line between belief and biology. From blood to beta activity, today's discoveries remind us history hides deeper truths. Like, subscribe and share your thoughts. Until next time, stay curious and keep exploring.